Hey, what is going on, guys? My name is Dev, and today we're going to be going through the HackerRank problem called Arrays Left Rotation. So what it's saying is that we're going to be passed an array, and it's going to have another parameter called d, which is the number of rotations we're going to perform on the array that we get. And they're going to be left rotations. So, for example, they give you sample input and a sample output. So they give us 1, 2, 3, 4 being the array, and 4 being the amount of left rotations we need to perform, and the sample output would be 5, 1, 2, 3, 4. So for example, the visual representation is actually pretty good. They give us 1, 2, 3, 4, 5, then the second iteration it'll be 2, 3, 4, 5, 1, then the third iteration it'll be 3, 4, 5, 1, 2, fourth iteration 4, 5, 1, 2, 3, and the last iteration it'll be 5, 1, 2, 3, and 4. It's a pretty straightforward problem. Typically with this problem, we want to use the Modulus Operator, and the reason is because if you haven't ever seen circular arrays before, the mod operator makes it really easy to actually calculate everything in a circular array for getting the next element in the circular array. It basically makes it easier to just calculate the front and back positions in a circular array. So whenever you see problems like this for rotating left or right of an array, or going through or looping through a circular array, typically we want to use the modular operator. So we can just get right into this problem. Basically, we want to create our new array that we're going to return. So we're going to say int array, new array is going to be equal to int array at, and we're going to set the length equal to the same length of a, because it's going to be the same number of positions. It's just going to be rotated. So new array is going to be what we'll be returning. Now in the for loop of this problem, we're going to be saying int I is equal to 0, I is less than a dot length, and then I plus plus. Now this is where the modular operator gets used. So we're going to be saying that in new array at position I, which is the 0th position, is going to be equal to a at position, now ai plus d, and modulus a dot length. So I will be explaining this actually in, I'll actually draw this up. So for example, we get the array of, one second here. Okay, so we have 1, 2, 3, 4, 5. Now this is visually what it would look like if this was a circular array. Just going through the problem, we have our first iteration of I of 0. Now in this example, if we want to start looping through the first element of the circular array, we want to say that d is going to be equal to 1. So if d was 1, we want to rotate this one time over. Now anytime we have anytime we have the number of rotations here, that'll be where we actually start off with in the circular array. So I'll just kind of show a basic iteration of just one position, because that'll be probably the fastest way of just representing this. So we'll go through and we'll say that 0 plus 1 is going to be 1, modulus 5 elements in the array is going to be equal to 1. So this is actually going to be the first, 2 is the first index, because 1 is the 0th index, so 2 is going to be the starting point here, and we're going to be moving this over 1. So when we have our new array at position I, we're going to say that since I is 0, this is going to be, the first element will become 2 now. And this is going to be equal to this specific here. So 1, or a at position 1, which is going to be 2. Now for the second iteration, it'll say that 1, 2, 3, 4, 5. Now we have I is plus plus, so I is going to be 1 plus 1. So it'll be 2 modulus 5 is going to be equal to 2. So we're going to say that new array of position 1, because I is 1, is going to be equal to a at position 2. So a at position 2 is actually 3. So basically this will just continue on and say that I is 2 now, so 2 plus 1, and it'll be 3 modulus 5, which is going to be equal to 3, and same thing in the same array. So 3, which is this array A at position 3 is going to be 4, so we'll set 4 at position I, which is going to be 0, 1, 2, so 0, 1, and 2. Now we have the next iteration, and this is just going to be I is 3, so 3 plus 1 is going to be 4. 4 modulus 5 is going to be 4, so 5 is going to be the next element, and 2, 3, 4. So now we say that this I at position 3 is going to be A at position 4. So that's good, and then we have our last iteration before we have the length check of I being less than A.length. So now we have 4 plus 1. So we're still good because 4 is still less than 5. Now we have 5 modulus 5, which is going to be equal to 0. So now A at position 0, which is 1, is going to be the new array at position 4, so it's going to be 1. And this is the basic rotation that we're going to do, and then the next check it'll say that 5, which is I is now equal to 5 in the 5th iteration, is not equal to, is not less than length. So now it's just basically going to step out of the for loop, and we're just going to be returning now new array. That's all we're going to do. So we'll come back to the code. And all we're going to be doing here is just we're going to say at the end, return new array. And this should basically work for all the use cases that we get. So I'm going to run the code. So this passed all use cases here, or at least the sample ones that we get. And when we submit code, it'll test this against the rest of the use cases and return back if it is good. And it was status accepted, so this is a good solution for this problem. Now, the complexity of this problem will be O of n. I'll just write it here. O of n being that n is equal to the length of the array. Since we need to iterate through the whole array, the complexity will be O of n time for this specific algorithm. So I hope you enjoyed this solution. I hope you understood more about why we use the modulus operator and why it's useful in rotation problems or with circular array problems. So I hope this helped you out. Thanks for watching, guys, and I'll see you in the next video.